Hi students. I guess I might be in Europe when you're watching this. Uh, I'm at home at the moment with my critters and they could possibly make all kinds of noises while we're doing this, but hopefully they won't. So our topic for this video is an algorithm that will take a regular expression and turn it into a non-deterministic machine. So it's the Rex to NFA algorithm right here. The Rex, whoops, sorry, I'm not so good at this little tool. The Rex to NFA algorithm produces those kind of weird looking machines that we practiced our NFA to DFA on. Lots of lambdas. It just depends on your regular expression how many lambdas end up being in the machine. Hopefully by now we have practiced plenty of regular expressions in the class, and so you're comfortable enough with regular expressions. Now what we're going to do is learn how you can make an equivalent machine out of any regular expression. Equivalent in the sense that the strings that the regular expression generates are the exact same strings that the finite state machine accepts. So here's how we're going to do this. We're going to take the regular expression that we wish to convert and write it. Let me make a new page here for a minute. I want to come back to this one. What if I can do another paint? You guys can see how inept I am at doing this at home. I want to make a blank or another paint window that I can use to just draw on. Oh, cool. Okay, so wonder if it remembers my settings from that other one. Let's see. I'm doing this with this size, and I can do it in black here. I had to do it in red on that other one for the contrast. Alright, so here's what we're going to do. We're going to make a machine that has two states, the start state and an accept state. And a great big old long arrow that goes from the start state to the accept state. And on this transition, we are going to write the entire regular expression. And then we're going to begin to decompose that regular expression one step at a time. And that's what this other page right here, that's what this is talking about. Make a start state and an accept state with a long enough transition between them to put the entire regular expression on that transition. Then you begin to break it down until all of the transitions of the machine have nothing on them but lambda or one character from the alphabet, or we also allow something like that. That's not one character, but we allow that. A comma B. We've seen that before. And here's how we are going to do that. We're going to find a transition that contains a regular expression instead of a single symbol. At the beginning, that's easy to find because it's sitting right on that one really long transition. Over time, some of our transitions will only have one character and be finished, but there'll be others that still need breaking down. So you find one that needs breaking down. If that expression contains an outer OR, in other words, an OR that is not buried within a set of parentheses, then we're going to break the expression down using the OR operation. We always do this breaking down business in reverse precedence order. We will do ORs first. If there is no OR that we can use, then we will look for concatenation. Can we use that? We always do it in this order, guys and girls. First OR, then concatenation, then the Kleene star. Reverse precedence. It's important. This is the way you screw up, is you don't do it in this order. So we look for OR, and if there is an OR, it could be that there's multiple ORs, could be that there's just one OR, but however many ORs there are, what you do to decompose this is just well, if it's a single A or B like that, you can do A comma B. The alternative would be to do one transition for A and one transition for B, like that. That's the alternative. But what you do, in general, is make an edge for every piece of that ORed expression. So here we have AB or BA or A star. And we decompose that by making three different pathways. That's the OR. See, it's giving the machine a choice. Either you use this pathway for the AB or this pathway or this pathway. That's how you break down ORs. Now, if you don't have an OR, then you look for concatenation. And the way you break down concatenation is by adding some new states. I don't know why this word concatenation is over there. It's supposed to be over here. Somehow when I was creating this file, that got shifted. It's supposed to be over there, concatenation. Well, here's a bunch of stuff concatenated together. Now, you can't get into this expression yet. This whole thing, including the star, is one element of the regular expression, because we haven't busted it apart enough to get in there yet. It's concatenated to this thing, to this thing, to this thing, and then to this whole thing as a unit. To break it down over concatenation, you add new states to separate the pieces that are concatenated together. So here's the first piece, and then the second, third, fourth, and the last piece of the expression. Once you've got this on its own transition, you don't need the parentheses anymore. You only needed them when it was part of a whole. Now it's all by itself, so you don't really need those anymore. So if you can't do OR, you do concatenation, and that's how you do concatenation. Now, if you can't do concatenation yet, because your entire expression perhaps is something like this with a star on the outside, and you can't get in those parentheses until you get rid of that star, so then you're forced to do the star first. And what you do, this is how the lambdas happen, you're going to put one new state in between these two states that you had over here, this state and this state. You're going to put one new state in the middle. You're going to lambda to it, lambda away from it, make a loop on it, and put the entire regular expression except for the star on that loop. This means you can do this thing in here 0 or more times. Well, that's what this allows. If you don't want to do it at all, you just slide and then you slide. If you want to do it one time, you slide over. You do it one time, you slide. You can do it as many times as you want, and that is the technique for breaking down a starred piece of the expression. All right, now we're going to go to the next page, which for me is rather a production here. So I have to open up the file called P2, which is your page 44. That was page 43. Where'd my opening thing go? File. Oh, there it is. About time. Okay, desktop. Where's desktop? Desktop. P2. No. Hope I don't regret that. Because now I'm not going to be able to go back to a previous page the way I sometimes do in class. All right, but we're just going to try this. So here is an expression. What this represents, in case you don't yet see it, this regular expression generates strings that do not have a BB in them. This little piece right here allows B's, but every time you choose this BA, you get a B followed by an A. So choosing that over and over again will never make a BB because it always has that A right after the B. So if you put two of them together, you get BA, BA. You don't end up with two B's right together. And you're safe out here to just add one more B if you want to, or nothing. So that's what this does. And we're going to bust it up. All right, so here's my machine. I draw better when we're in class. The only problem with this algorithm is you end up redrawing your machine a whole bunch of times. That's okay. A or BA, quantity starred, followed by either one single B or nothing. Alright, so now we have to bust that up because it's certainly not just one character from the alphabet or lambda. Remember what we do. OR first. See if you can do an OR. If you can't, see if you can do a concatenation. If you can't, see if you can do a star. You got to be able to do something or the thing would be finished. Alright, so we cannot yet get to these ORs. They're buried inside parentheses. They are not what I would call outer ORs. So is there concatenation? Turns out, yep, there is, of two things. We have this piece right here concatenated to this piece right here. I hope you can see this little tiny dot moving around on the screen. It's pretty small. But I hope you can see it. Two things being concatenated together. That means we break it up using that technique of putting a new state in the middle. So here's my new state. The start state and the accept state are still the exact same, but I've added a new state in between. And what I'm going to do is put quantity A or BA starred here and B or lambda here, and I don't need those parentheses anymore because there's no star or anything. Alright, so I'm not finished. I have to keep going. Let's do this piece and then we'll add on what we get for this piece. Alright, so the first piece, there's an OR, but it's buried in parentheses. Concatenation here, but it's buried in parentheses. We have to get rid of this star, and so what we're going to do is put a state in the middle, lambda to it, lambda away from it, lambda, lambda. Now a lot of people, when they do this algorithm, they will be too smart and they will think, oh, I don't need both those lambdas, I'll just leave one out. Don't leave one out. I want everybody to put them in so that all the machines look exactly the same when I'm grading them. Put them in. Don't be that clever and leave them out. Even though they're not necessary, put them in there. Alright, so then we put a loop on here, and my dogs are going to make noise here in a minute. And we take the star off, this star, and we put A or BA on that loop. Alright, that's that piece so far. We're not finished, but we'll come back to it. Now over here, we can do an OR. It's not buried in anything. And so what we do is we will have one transition labeled B and one transition labeled lambda. I suppose you could put B comma lambda. I don't usually do that. I don't mind A comma B, but B comma lambda is almost like you're saying either the character B or the character lambda. And we all know lambda's not a character, so I don't typically do that. If you did that, I wouldn't count it wrong. I just personally wouldn't do it. Okay, so we have everything except for this expression right here finished. This is the problem with the algorithm, is you end up redrawing things a lot. Sometimes you can do this in your head, so you can go straight from the beginning to the end for a simple expression. But the hard part for me in grading that, if you do that, is if you made a mistake, I don't know how much partial credit to give you unless I can see your work along the way. So it might be better to redraw at least one or two times. I will only be looking at your final product unless it's wrong, in which case I will go back to the previous steps and try and figure out how much of an error you made. Okay, so we are looking at, hold on, I have a dog you can't get on my lap right now. Get down. Where's my cursor? I've lost it. Where's my cursor? I don't know where I'm going to draw. Okay, right there it is. So we're looking at that expression there. It's the only one we have left. And first we consider or, and we realize, yes, we can break it down over or. And so down here, we will have one. Now, remember how you do ors? You just add edges. One new edge, or you'll end up with one edge for each of the pieces that are being ored together. So here we have an edge that is leaving and coming back to the same state. Sparky, I'm not kidding. Get off. I've got so much stuff in my lap. I've got this Wacom thing and my other mouse. He just can't sit in my lap right now. Okay. So I have two things being ored together. That means I need two edges that are going from and to the exact place this one edge is doing now. So I end up with the one edge for A and the other edge for BA, like this. We're almost finished, and I believe you wouldn't mind too much if let me find my cursor, if I erase this little piece right here and fix it. This is going to need to be broken up over concatenation, which means I'm going to need a new state right between the B and the A. And so let me come up here and get my eraser. And erase this. Oh, this is too little. Okay, so I bet you wish you had a professional video maker here. All right, so we're trying to do BA. What we're going to do is separate them with a state in the middle. So B is going to leave and go to this new state, and then A is going to come back like that. And now that machine is finished. All you'd have to do is number your states if you wanted to remove the non-determinism and then go forward. So that's how we do that particular regular expression to machine. Now let's see if this makes sense to us. The regular expression was you can have A or BA as many times as you want, and then after that you can either have a B or you can be finished. So down here looking at the machine we made, this says you can either have an A or a BA as many times as you want. I'm sure this seems a little familiar because we looked at a bunch of machines back a couple weeks ago that looked like this. A or BA as many times as you want, and then you can slide over when you're finished and keep sliding all the way to the accept state and be completely done, or you're allowed to have one more B. So yes, that makes perfectly good sense to me that this machine came from that regular expression. Now I know that some of you, maybe all of you, could just go straight to a deterministic machine for that regular expression. It wouldn't be too awfully hard, I don't think. You'd have to be careful because you do have this starting with B and then this starting with B too, and you'd have to be careful about which state you made your accept states. If you didn't want to think that hard, you can always use this algorithm, make a non-deterministic machine from the algorithm, and then convert that to a deterministic machine using NFA to DFA. Okay, now let me open up page 3 and we'll go on to the next page. No. All right, so here's a new one. And we're told that this regular expression is for strings that either contain AA, which is this regular expression right here, or are even in length. This regular expression right here. All right, so here we go. Put that whole big long thing on one transition over to an accept state. So we have the AA substring part. So we have A or B star followed by AA followed by A or B star. Or, this is a union language, or even length strings. And we're doing that by saying take an A or a B and then take another A or a B. So you've got two characters. And you can do that as many times as you want. And if you glue together two things over and over and over, it stays even. Okay. So remember the order in which we do things. It's very important to get this right. First or, if you have it, then concatenation, and then star. So you look at this and you say, yep, I've got an or. It's this or right in the middle. So I am going to break this expression into two pieces, a top road and a bottom road. This bottom one is for even length strings, A or B, A or B. Top one is the substring AA, or regular expression. A or B star, AA, A or B star. All right, now we just keep going. For this piece, we can't get to the ors. They're buried. But we can get to concatenation, and we have four things here. We've got the A or B star part, then an A, then an A, then an A or B star. Four things. Down here, we can't get to the ors. We can't get to this concatenation yet because all of it's buried inside this star. We got to get rid of that star first. So let's do the pieces separately. Top one is concatenation. So we'll put A or B star here. Then A. Then A again. Then A or B star. I hope you're doing your worksheets while I'm doing this. That's sort of the goal. Alright, so that one's broken down over concatenation. Now this bottom one has to be broken down over star. So lambda to a new state. Lambda away from that state. We only add one state when we do a star. And we will, let me scroll down a little bit. I'll put that loop-de-loop thing at the bottom. Put your loop. And you're going to put everything but that outer star on it. So you're going to have A or B followed by A or B. Alright, so we got rid of that star right there. And now we have two things concatenated. Up here, let's see. We got to get rid of that star and we got to get rid of that star. And then, since these are A or B's, very simple things, we can use A comma B on that. So I think we can finish this up pretty quickly. Let's see. Alright, so I've got to do a new state in the middle here. Lambda to it. I'm getting rid of the star on the outside of A or B. Lambda to it and lambda away from it. Put your loop on there and put everything but the star on it. In this case, instead of putting A or B, I can put A comma B. I'll do one of them that one way and the other way. So I'll show you both options. So here is the easier option. Just put A comma B on there. And then you have A followed by A. And then you have to do that same thing again. Here's my accept state sitting over here. Put your new state in the middle. Lambda to it. Lambda away from it. This time, instead of doing A comma B, I will do one road for A and one road for B. Those are equivalent options. I usually do this one just because it's quicker. All right, now this down here, the lambdas are fine, but it's this right here that's the problem. And what we have are two things concatenated. We can't get to those ors yet. We have to break it up over concatenation. So we're going to have a new state kind of like right there with one part coming to it and one part going away from it. So when let me just draw this thing. I'm going to move that state, this state right here. I'm going to move that to right here and make it kind of go straight across instead of scooping down so that I have a little bit more room. Okay, so lambda to it, lambda away from it, just like before. And then to break that up over concatenation, I need a new state. And I still need to keep the direction of this loop. You know, I'm leaving and coming back to the same state. I still got to do that. And now this is A or B, and that's A or B. So let's just finish up. Let's just say A comma B here and A comma B right there. And that's it. That's all finished, the whole machine. Okay, so that was page 45. Now let's go see what's on page 46. Y'all can see my desktop files here. You like this game, Braid? That is the coolest game ever. Okay, page 4, I think is what we're on. Come on, open up. Oh, don't save. All right. So, a couple things on this page. I want you to write this regular expression right here on your cheat sheet that you're building for the exam. This is hard to come up with on your own. You can understand it once somebody else comes up with the thing, but it is the regular expression that goes with the language even. And we've probably talked about this in class. I'll assume that we have. But this part keeps the A's even because you're taking two A's. This part keeps the B's even because you're taking two B's. If you don't want contiguous A's right smack together, then you take 4 letters instead of 2 letters. This can either be an A or a B. Actually, you could take more than 4 because this middle part you can put letter pairs in there. So here you can take one A and one B arranged in either order, and out here you have to take one A and one B. Thus you're taking at least 2 A's and 2 B's, but you can have more than that if you want because there's stuff in the middle. And if you concatenate all kinds of different of these patterns together, you can make strings that have even A's and even B's, and you can make every string that has even A's or even B's and even B's from that expression. Sparky, I'm not kidding. Get off. Get off. Okay. So this is going to make a mess. I'm probably going to need to make my page bigger, but we'll see. I'll just try not to. All right, let's put the whole expression on one transition. I'm going to break these videos up into different algorithms. So if you think you've got this algorithm right now, you just fast forward through all this mess and check your, just go ahead and do this one yourself and then fast forward and see if you got it the same as I did. Because I know this is kind of drudgery to watch somebody do this. It won't hurt my feelings a bit. I won't even know. All right, so that's the regular expression right there. Oh, and there's a star on the outside. Okay, so first thing you do, you say, can I get to those ors? No. Can I get to the concatenation? No, because they're all buried inside that outermost star. So what we have to do is make a state in the middle, lambda to it, lambda away from it, put a loop, and put that entire thing, psi, put that entire thing, AA or BB, or that whole big thing, AB or BA, followed by AA or BB star, followed by AB or BA. All we got rid of was the outermost star. And we have all the rest of it, what we had before, but now it's on a little self loop. Okay, so that's all we have to break down. Is, remember, the order in which we asked the question, is there an OR that I can get to? And the answer is yes, there's actually two of them. So what we're going to have are three loops off of this middle state, because there's three things being ORed together. There's an AA, there's a BB, and there's this great big long thing. All right, I know how to fix. If I did the three ORs and didn't want to rewrite the whole machine, like if I put AA right there, and then I could put BB, then I'd have to erase and fix this. But don't you know how to fix this right here? This is two A's concatenated together. So you could just go ahead and put the state in between those two A's and break that little piece up over concatenation. So let me just do the AA and the BB and finish those up. I'll not shortcut that other piece because that's kind of a mess, but I want to shortcut this one. So I will have to add a state here and go there on my first A, and then come back down to the state I was in for my second A. So there's AA. I'll do that same thing for BB. There's the AA or BB. See, there's the OR at play. You can either do this, AA, or you could do this. That's the OR. But now I've got to do this great big thing. So why don't we go ahead and bust it up over concatenation while we're going. We've got three things being concatenated together here in this third piece. And so let's just go ahead and break it up over concatenation. So here's the AB or BA piece. And then we've got the AA or BB quantity starred piece. AA or BB quantity starred. And then come back to where we started on the second AB or BA. All right, we're not finished because these pieces right here need further work. Oh, I forgot to put my lambdas here. That was a lambda and that was a lambda. All right, so I'm going to redraw that top part. You guys just fast forward. AA or BB. So here's A, B, B. Now, this you need to break up over OR, and then each of the two little pieces get broken up over concatenation. So first I'm going to place this state kind of over here. Where's my cursor? Where'd it go? Okay, right here. So I need one road for the AB and one road for the BA. So here's my road for the AB getting busted up over concatenation, AB, and here's my road for the BA, B, A. So I did 2 steps there in one swoop. I broke it up over OR and made 2 different roads, one for the AB and one for the BA. You see, you're going in order here. So here's A followed by B, and here's B followed by A. But then those 2 things needed further help because they needed to be broken up over concatenation. So I went ahead and did that. Now this bottom thing is first going to be broken up over star, and then over OR, and then each piece over concatenation. So I might just do it and then erase it. So the first piece, here's this state right that I just drew, that's the state right here. Alright, so first to do the star, I add one state in between, lambda to it, lambda away from it, put a loop, and on that loop put everything except that outermost star, which is AA or BB. If I want to go ahead and finish, how do I do that? Well, that means I need one road for the AA, because I want to break it up over this OR, one road for the AA and one road for the BB. So I'm going to put my BB down here. This is the BB. And I will take off the OR BB from that top thing. Hold on. Okay. But then each of these, this AA and this BB, they need to be busted up over concatenation. So I'm going to do that. I'm just going to stick a new state in between. I'm getting a little cramped here. Where'd my little cursor go? Okay, so here's the AA, A, A, and the BB is down here, B, B. Alright, so either an AB or a BA followed by any number that you want of AA or BBs, followed by the same thing but going from here up. So here's the AB, and here is the B, A. First we broke it up over OR, separated those 2 different substrings, AB and BA. See, here, had to break that up over OR first. And then each of those 2 things got broken up over concatenation by adding the new states. And that's finished. This is a non-deterministic version of the even machine. If you were to take this non-deterministic machine and do the NFA to DFA and then minimize, you would end up with that 4-state lovely little parity machine that we know so well. The one that the trains made and the one that we've looked at over and over again for even. So isn't that cool? Yeah, it's kind of cool. Alright, so is that the end of the whoops, I don't know what that was. Let me kill that. No. I had my worksheets open here a little bit ago so I could see if that was the end of the Rex 2 NFA. Where's my worksheets? Nope. Oh well, I'll just open up the next page. This was page, what, 45 or something? Oh, I've got it. Page 4. That was page 4. Let me see what's on page 5. Page 5. Ah, okay. So let me tell you something. This is important because it will affect how you study for the exam. We just learned an algorithm that will let you take a regular expression and turn it into a machine. There's another algorithm that will take a machine and extract from it a regular expression. We call that one NFA to Rex. It goes the opposite direction. Take a machine, and by the way, although this says non-deterministic machine to Rex, all the non-deterministic finite automaton category is more general than the deterministic finite automaton category. And so you can run this on deterministic machines too, and it'll work just fine. This is the important part. I am not going to test your understanding of this algorithm. So I'm going to explain this algorithm in a video, but it is completely optional. You do not have to watch it even. If you're curious about how this works and you want to know the algorithm, then watch it. But I'm not going to test you on it. For the last probably 2 years, I have not covered this algorithm in our class. We just don't have time during the regular semester. If you look on the agenda, you will not see this algorithm listed on a day. But since we're watching videos for this little section of the course, I'll throw this in just so you have this for your own understanding. But again, you do not have to study this for the exam. It's just kind of a curiosity. And the reason I don't feel so bad about leaving this out is that it hardly ever makes a really nice regular expression. And it's possible to get multiple different regular expressions out of the same machine because of what you're going to be doing is removing states one at a time until you're going backward from the Rex to NFA algorithm. You're going to start putting the transitions together into little bitty regular expression pieces, and eventually you will have only a start state and an accept state left, and the entire regular expression will be on that one transition. But you do this by removing a state at a time from your machine. The order that you pick to remove those states changes the resulting regular expression. And so you could run this algorithm on a machine, somebody else could run it, and you could get 2 different regular expressions. Now, if neither of you made a mistake, they would be equivalent regular expressions. They would do the same job. They would both be correct. But one of them could be a lot longer than the other one, just messier and not as concise and understandable. So I don't know, I just never really liked this algorithm. And so I want you to realize that there are algorithms to go back and forth from machines to regular expressions either direction. If you've got like a machine, you can have a regular expression. If you've got a regular expression, you can have a machine. We have algorithms to go both directions. But this one, you don't have to learn if you don't want to. So I'm going to stop the video here. Then I'm going to make a new video for this NFA to Rex algorithm. And just keep going with the next topics too after this one. All right, thanks.